Thank you. Thank you for this warm welcome and inviting me for this lecture. And you can see the title of this topic, that is the farming microgrid. I hope that you are not anyone from the electrical background. So I'll start from the beginning, that what is actually farming microgrid and why we move to that. So that is also, like, that the country is moving towards sustainable development in all the sectors, not in agriculture, in electrical, in medical, every sector. So if you see the sustainable goals set by the United Nations uh, few years back, they have set 17 goals to transform the world, to make the life better for the people. So there few points you can see. That is, the first is the zero hunger. That means the agricultural production will be that much sufficient that the hunger of all the people in this world can be fed properly. But if you see the seventh point, that is the affordable and the clean energy, because still in our country we have so many thermal power plants, right? If anyone is from Bihar or Jharkhand or the west part of the West Bengal, you can see multiple number of thermal power plants. So what actually we burn in thermal power plant? That is the coal or oil, and that is producing the electricity for us. So for burning a coal, that means, if you like surprised to know, each thermal power plant efficiency is 30%, 30 to 35%. That means if you burn almost 1,000 kilowatt hour, like 1,000 times energy, you will only get 350. So very less amount of energy we are getting out of our thermal power plants. But we are actually emitting huge number of carbon dioxide, sulfur dioxide for it. So the main goal is to move towards the clean energy. And you might know about the solar panels, wind farms you have seen in your uh, neighborhood. So the actual goal is to get this affordable energy and then use that energy for each and every sector. And agriculture is not out of that. Okay. So previously, if you see that how this agricultural field is modifying, so first, the animal or manual works are mostly been done in all the village areas, but we are now moving towards the electrical equipment. That is the tractor. That is an electrical equipment, which is actually burning your diesel, and from there it is running. Then the second, if previously we have the diesel run irrigation pumps, now we are going to the electrical running irrigation pumps. The like the growth of electric motors, because previously all the works are done by manual. Now we have several harvesting machines, seed drying machines, conveyors, belts, everything we have, and everything is using actually electrical energy. If you see at your house as well, we cannot stay even in 1 minute without electricity. Even in this room, if we switch off all the lights and the AC, we'll just go out of this room instantly. Okay. So with this, what are the impacts we are giving to this world with this paradigm shift we are getting in the agriculture? I will specify my talk only in the agricultural sector. But what are the changes, or what are the impacts we are getting? Some are obviously positive, some are obviously negative. The first is the productivity gains, right? So that means when you are automating our services, that means we are moving from manual to a automatic machine, tractors. Obviously, like one person, he can only pluck his field 1 bigha or 2 bighas. But if we go to a tractor, it can do it in 10 or 20 bighas in a day. So obviously that will increase our production. Even for the harvesting, if you use any harvesting machine, that can take the all the crops entire field within 1 day. But that is not possible for a person or a cow. So the productivity gains obviously we are getting. Second, reduced labor intensity, because depending upon the season, depending upon the areas, we are struggling to get the skilled manpower who can do these agricultural works. So that reduction is also we can experience. And obviously the post harvest loss reduction, that means as we can do the entire work in a very small time frame, we are not wasting any kind of crop in that field on that time frame. So these are the three advantages. Now what is the disadvantages? First disadvantage, obviously these machines are quite costlier, and all the farmers, they cannot afford it, right? That is the first thing. Second thing, to run those machines as well, you need a skilled labor. Anyone cannot run that machine. That is the second thing. Third thing, if you see that the electricity demand or the crop demand, how much agricultural feed needs, that is not a constant quantity. Sometime, let's say in the summer season, you need more irrigation pumps to be run because you need more watering to your paddy fields. But you come to monsoon, then you have already good amount of rain. So at that time, you don't need that much of irrigation. So this variation is there in the agriculture sector, and that creates the problem to the electricity network. Because as an electrical operator, I should know what my customers want, and I have to know it on the seasonal basis. And that is quite difficult to do at this stage. Okay. And the last one is the environmental trade-off. What I told from the beginning, that we are moving from the diesel to electrical, diesel to electrical. But from where this electrical is coming? Ultimately from the thermal power plant. So you are reducing the diesel burning, but increasing the coal burning. So ultimately the entire emission is keeping constant, right? That is your like sustainability to the agriculture is not giving you the sustainability to the entire system as a whole. Like you are making your electrical system more and more unsustainable. So how to get rid of all these challenges? So if you see what are the current scenario of agriculture sector in India, it is the third largest consumption in our country. For before that, you have obviously industrial sector, which is almost 41% of our country's consumption, followed by the residential, which is 25%, and then the agriculture sector, which is 17%. And from 2010 to 2024, it is keeps on increasing, and it is increasing day by day. It's like people are adopting more and more electrical equipment to get their productivity, increase their productivity. And within this entire consumption, 70% of the electricity usage is actually for the irrigation purpose, for the pumps, for the electrical like lighting, and other things we use for the agriculture sector. So if you increase and if you agriculture production, if you want to increase, because our population is growing for the entire world only, it is growing. So our food requirement is also increasing. That means we have to increase the agriculture production as well. So if you increase the agriculture production, your usage for the electricity will also increase day by day. So how to cope up with this, like other than burning the coal anymore? That is the main idea of the entire, not only the nation, it is the idea for the entire globe. And actually, if you see the Nordic countries like Finland, Denmark, Norway, their thermal power plants are completely shut down. They don't have a single thermal power plant in their country. In our country, we have almost 60 to 70% power from thermal. Rest of the power we get from hydro and renewables. So that actually we need to reduce. That is our challenge. Nordic countries, they are fine because they have a good amount of wind energy. So they are good with that. And their population is also quite less. But in our country, though our geography is so diverse, the problem is that where you have a big consumption, you don't have that resource. If you see where which part of the country has a big consumption, electricity consumption, that is the South India. If you see all the industries, all the commercial hubs are in South India. But South India rarely has any renewable sector. Only the Tamil Nadu and the Kochi sector has the wind power. The wind is high. Like, forget about the power, wind is good. Like, you have a coastal area, that means you will get the wind. Where you will get solar, like good sunlight, that is in Rajasthan area. But Rajasthan doesn't have any industry. Where you will get the good hydropower, Himalayan region. Himalayan region barely have any residential load as well. So where you have generation, you don't have consumption. And where you have consumption, you don't have any generation. So that is the problem, that you have to evacuate your power from, let's say, to the Tehri power plant, which is at the Uttarakhand, to the Bangalore. So it is almost 3,000 kilometers. Your power has to travel from Tehri to Bangalore. And within that distance, whatever power you have generated at your thermal power plant, that will get lost in that middle. It will not even reach to Bangalore. So that is the problem with the India, that they cannot survive without thermal power plant. They cannot make it zero, but at least we can minimize it in few sectors by doing a localized power generation. This is the energy statistics published by Central Electricity Authority. No, this is the overall Indian perspective. So what are the goals of, before proceeding to agriculture sector, what are the goals of renewables of India? As I told, that first is that India has promised in COP29, like Conference of Parties 29 in Azerbaijan, that they will integrate at least 500 gigawatt of renewable energy by 2030. And our Viksit Bharat uh, aim is to become net zero. That means we will not produce any emission by 2047. Okay, so that is a small step towards that 2047 goal that will integrate 500, but still we are at 102.56 gigawatt of solar power. And we have to move to almost 300 gigawatt by 2030. So we have only 4 years time to make our solar panel consumption 3 times, or solar panel power production 3 times. And that is not an easier task. That is not an easier task, but actually the thing is that if we motivate people, what is normally done, if you see that one is PM Surya Ghar Yojana, where at least the residential loads can come under the umbrella of solar or renewable power. PM Surya Ghar Yojana. This is actually the solar potential. That is actually the solar potential. If you see that, actually I am not recognizing that, but if you see the light color, that means it's a lower potential. If you go to more darker one, that is actually your more solar power is. Red is more potential, but harvesting that potential is very challenging. Because if you see this area, as I told, this portion, you have good solar potential. But the thing is that solar energy is not constant at that place. If you see south, if you go to South India, it is sunlight now. After 1 year, suddenly it will start raining. If you go to Chennai. So actually that is bad for your solar panel, because the temperatures are keeps on varying within a day drastically. And that is not quite acceptable for a good solar panel efficiency. So we'll see what is actually a grid before the microgrid concept. So you know pond, right? Where waters also go inside and you can take out of it. Electric grid is like a pond of electricity, where as a generator, I will put my electricity there, and as a consumer, you will take out your electricity from there. So it's a big pond where the power comes from your thermal power plant, your wind power plant, your solar power plant, and anyone from it, like your home, electric vehicle charging station, or any kind of industries, they can just take out the power from that grid. So there's a brief idea about electric grid. Now come to specific to the agricultural system. How the conventional agricultural system or conventional electrical system in the agriculture look like. You have all the irrigation loads connected, and mainly they are taking power from a local distribution network, local rural distribution network. You have no other options. If the power goes out, you just turn on your diesel generator. Okay? Like, because most of the rural India, like we have almost 5 to 6 hours of power cut. Okay. So especially in UP, where I am coming from, our distribution sector, they told that our average in the city areas, it is 22 hours or 20 hours. So you can think about what is happening in the rural areas. So this traditional agriculture system, they mostly relies on our national grid. And the rural India or the rural sector is the least prior in for the electrical authorities. As an electrical engineer, I am telling you that rural India is the least priority. First priority comes to the industrial sectors. If their demand is met, then we go to the commercial sectors. If their demand is met, then we go to the city residential areas. If their demand is also met, and how much power you are left with your grid, that will go to the rural area. And that is why the major amount of power cut you will see in rural India. So if it is that, that means if your power is not constantly you're getting, that means you will constantly keep on increasing the integration of your diesel generator, right? But that is not favorable. So again, the government of India has introduced another scheme, which is called PM Kusum scheme. And that is actually done in three sectors. First sector is that to install 10 gigawatt of a solar pump, which will only run with the solar panel in the village areas. The second is to replace your already grid connected agricultural pumps with the solar pumps. And the third is that to get at least solarize 15 lakhs pumps depending upon your conventional grid. So to reduce the consumption, like to make your system more and more sustainable against the grid. So that is the main goal of Government of India. So this PM Kusum scheme is launched and it has been done by next year. Okay. So though it is still not very popular and it is not like been done also properly, but still the Government of India, they are trying to do. Huh? No, they are trying to do it, like they are motivating us, like as an IIT, the UP government approach to us that you go visit the places. Actually, the problem with the rural India, I am telling you, whenever you go to a village and tell them that we want to electrify you, they think that we came for the billing. We want to take their money out from them. Okay. So they don't allow us to do all these things. If you go anywhere, like if you say that आपका diesel generator हम replace करके हम solar लगाएंगे, तो उनको लगता है डीजल तो हमारे हाथ में था, सोलर इनके हाथ में चला जाए, अभी हमें उस हिसाब से बिलिंग करेंगे. So that is the problem. So that is why this PM Kusum scheme is not very popular, but still government is aggressive to do with this work. So now what is the relation between this agriculture and the electrical? For the last 20 years, they are trying to merge with each other. Previous to that, they are completely separated and there is no link between them. And now it is doing because of this sustainable development or sustainable energy production. The first point is that I told that about the machineries, right? Your agriculture relies on electrical machineries, lighting, irrigation. So that is can be met with the help of renewable energy. Second is the complementary mechanism. That means when you have that renewable energy, like your solar energy with you, and you are not consuming, you can sell back that energy to the grid and you can earn money. That is normally done in urban areas, like if you have a rooftop solar, that we call it as net metering. You are consuming 10 kilowatt, you are selling 3 kilowatt, so you will be actually billed for 7 kilowatt. Okay. So now your agriculture loads are variable that I already mentioned. Then your local usage, like if you don't consume, then sell it to your neighbors or you sell it to your grid, your rural grid or the service provider, whoever is present. That may be a government or maybe a private sector. Because every private sector, even if you see the big electricity service provider, that may be your Reliance Power or Adani Energy, everyone get their license renewed if they have a good amount of solar or wind energy integrated with their system. Otherwise, their license will not be renewed. Okay, so what normally the common practice, because building a big solar farm, that takes a huge amount of capital investment, as well as that will take a huge land as well. So generally what these service providers, they do a contract with the locals or local your farmers or any residents, that you install a smaller solar rooftop at your roof, and whatever energy you will generate, you just sell me back. You use at your own. Like if you have a 5 kilowatt of panel, you use 2 kilowatt and 3 kilowatt, you give it to me. So combine, let's say you have 1,000 customers, combine this 3,000 kilowatt or 3,000 amount of power. That means it is around 3 megawatt. That comes as a 10% of its entire selling to that village. So he can show it to the national grid or to the government of India that at least 10% I am generating from my renewable power. So then he will get a good benefit from the government sector. That is another problem. The subsidy, it was given previously, And whichever country has given this subsidy, it has been backfired to him like anything. It is subsidized. Yeah, it is still in subsidized. It is not stored. It is actually, let's say, everyone is not having rooftop solar, right? Let's say you have, she doesn't have. So it will take power from you and sell it to her. That's it. Why you will not get? You will just get your power when the sun is there. No, it will. No, electricity is off not at your end. Electricity is off at the substation end. Okay. But this power can only go back. Let's say you five are staying together. Okay. I have to install a switch between you five, not at the substation. This is not a very easy mechanism that what is conventionally done now, that only one switch is there to control all the 1,000 customers. There will be a connection between you and her. Okay. And that connection will be controlled by the service provider. And he will just evacuate that power from your end to her end. That is a thing. This is what I told. That is a desirable thing to get the renewable done. But still, it is very infant stage. Even if your consumption is 10 kilowatt or 20 kilowatt, people are installing 5 kilowatt. So they are not meeting their own demand. How they will sell it to the grid? That is the thing. Like government is subsidizing the solar panel, but government is not subsidizing the battery. Like if you have a more power, you can the if I have the solar panel, I don't want that I will sell it to you. But at my evening time, when I actually need that power, I will buy from my service provider. So what I want, whatever I will generate, if I'm not using it, I will store it my end. And evening again I will use it. But that is actually not inverter means that is the battery actually. What we call it as an inverter in a local language, that is a battery cost. That, that inverter is just for the conversion. That is not for the selling. That is for just for the conversion. You you get the solar panel, you get the DC, you need to convert it to AC. That's it. Yeah, that is the problem. That I told that this is the big problem with the Indian sector to get the renewables. Because most of the time our electrical energy is not available to us. So that is the biggest problem. So, but now almost you can say 99% of the total capacity has been built. But actually, it is not like you have electrical like power in your grid and you can buy it. It depends upon your service provider. I have to go a little bit back of that story, that it is a bidding thing. Let's say you are supplying to a rural customers and she is selling to a urban customers. Obviously, her customers can pay her more rather than you. Okay. So whenever she will go to the bidding market, she can ask that I will buy the energy of 7 rupees per unit. But you will ask in how much? 3 or 4 rupees per unit. So as a seller, whom I interested? To the 7 rupees. So I will not give you power. It doesn't mean that I don't have. I have, but I will not give it because you are not giving me a profitable business. So that is the major compromise. So that is why what is favorable now, these distribution networks, what is favorable like from the agriculture point of view, and we are suggesting the government that make your village sustainable. Don't connect them with the grid. You install more and more solar panel. You install more and more biomass sector. You install more and more battery in the village as well, that they don't need power from. You make your village sustainable. It generate the energy at the local level, store at the local level, and then sell at the local level. So this is the features of a smart agriculture. What I told, that first the thing, you have to make your system sustainable, that your power should be available with you 24 hours. That power may not be your grid power. That power may be your renewable power. Okay. And you can control your all your irrigation, your lighting, even the residential loads of the village with the help of that much power. And replace all the manual work with the help of motoring work. So what you told, this is the main architecture. If you have your local energy supply, if it is more than that, then you sell it back to the grid until unless you have that grid at your place. Like the grid is connected with you. If you don't have, then store it at the local level. So you have three plans. First plan, you use it, consume it. Second plan, you can use it for the residential purpose. You can use it for the agricultural irrigation purpose, or you can store it at the with the battery and then use it later. Because whenever most of the cases we have solar energy, that is the daytime, we as a home person, as a residential person, we don't consume energy. When we consume energy, when the sun sets. Okay. At that time, we don't have that power. So it is better you store at the peak solar time and use it at the evening or the night time. For that, you need a battery. And the battery cost is still very high. So that depends upon the government to install that battery. No person can alone can install a huge amount of battery at his place. That is not safe as well. You might be knowing that, I don't know whether you are aware of that or not. Almost 3,000 cars burn out in the middle of the sea because lithium and battery, like normally, if something set on fire, you can just extinguish that fire with the water or carbon dioxide, like those cans. But just one car got fired within the 3,000 cars, which is traveling from the US to UK. And within the Atlantic Sea, that one car just got fired. And within 15 minutes, entire ship got fired. Because it is very hard to extinguish the fire of the battery. So that's why it is not even safe to install a huge amount of battery inside your home. So that is normally been done by the government at the local sector. I will show you a few examples. I was associated as well. So first option, how you can integrate the renewables with the agriculture. First concept came, which is called the agrovoltaics. Whatever the PV panel we have, we called it photovoltaics. Photovoltaic added with the agriculture sector, that is called the agrovoltaics. How the agrovoltaics is done, might be you have seen. You have solar panel placed at your agriculture sector, agricultural land, and beneath of it, you are cultivating your food. Okay. So that is actually a use of one single land for dual purpose. You are generating also energy. That means you can earn money from two sources. You generate energy, you sell it back to your service provider or to anyone else. Then you will get money. And also from that, your crop also, you can sell it back and you can get money. So that is the benefit. What is the disadvantage? First disadvantage, you are shading your crop. That is the first disadvantage, which needs a good sunlight. That crop cannot be cultivated beneath of your solar panel. That is the first problem. Second problem, even for the solar panel, the temperature matters, right? Because it can only generate energy when the panel cells, like the panel temperature will go above a certain amount. Like only the solar irradiation is not enough. Even the temperature is needed. Okay. But whenever you will keep a crop down of it, what will happen? It is constantly, it is giving you humidity, like it is evaporating water. So that water will be there at the bottom side of your panel, and that will reduce the temperature of the panel. So that means that will reduce the efficiency of the panel. So if you see, I have put a case study where at least if you put the soybean and then you put a solar panel 4 meters above it, but still your panel temperature can reduce by 10 degrees centigrade. And 10 degrees centigrade reduction in the panel will reduce the efficiency of 35%. And the solar panel efficiency is also very less. If you install a 5 kilowatt panel, for that, how much investment you have to do, the return is 40% maximum. That is also another disadvantage, or I could say the research limitation of the solar panels. So these are the agrovoltaics. That is in the very local level. The second comes the greenhouse concept. I hope that few of you know about what is greenhouse. That within a artificial environment, you cultivate your crops. That may be any vegetable, that may be anything. And that power from for that roof greenhouse, you will get that power from your solar panels. Okay. And use that power to your giving your AC is on or your irrigation pumps on, use it. So that is the your photovoltaic greenhouse. Then the if you go to little bit larger, that is called a farming microgrid. Here comes the concept of microgrid. Now, what is microgrid? What I told, what is the grid? That is a big pond. Microgrid is a smaller pond. So this is a smaller version of your entire electric grid. What you told that if you don't have grid, you cannot sell it back. So form a grid with inside your village. That is the idea. You have your solar generation there. What is actually grid? You have generation load together. So make your village like that. You keep your generation there. You keep your load there. That is already. So you just make an islanded or an isolated version of your international grid, that downscale it and make it at the village level. So what will happen? That you will make yourself sustainable. So this is that concept of farming microgrid, where you will have your solar panel, you generate that power, use that energy for your irrigation purpose. Okay. And that will obviously reduce your electricity bill as well, because you have your own cheap energy. You are not buying, so you need not to pay it back. And then this is the bigger rural microgrid. What I told you, that has been actually been done by us in the Kanpur area. There are two villages were there, two village hamlets. One is at Chabanivara and one is at Bagaria Purva. These are the two hamlets which have not been electrified by the government of UP till 2020. And I was associated with this project during my PhD and after also my PhD. So we took that village and we have seen that they have electrical appliance, but they are not using it. They have good amount of electrical appliances with them. Okay. They have fridge, they have ACs, they have their dryers, but they are not using. I don't know from where they bought it and why they bought it. But they are not using it. It is just kept as an just like a showpiece. Okay. The major problem what we have faced in this project, first is that they thought that we came for billing. We'll install all this solar panel, your inverters, your batteries, the biomass plant, and then after that, as IIT, I was in IIT Roorkee and IIT Kanpur was the lead out in that project. IIT Roorkee and IIT Kanpur will ask money from them. So actually, it took 1 year time to convince them. And we have to hire few NGOs. We have to talk with the MLAs, we have to talk with the MP, and the major problem is that within that time frame, actually the MLA got changed. So again, we have to start from the beginning to convince them. Okay. And the irony is that the new MLA came from the opposite party. So the first one, he approved it. And the second time he thought that, no, this is not a good project. So we have to just rubbish it, throw it out. So we have to make them take them into confidence that this is not going to harm them. That is the biggest bottleneck, you can say. This is the UISS. This is the Indo-US project. Yeah, from here, the DST was the funder and US was the DOE, Department of Energy. That is actually been done that to take few pilots and to electrify them. So the major goal of that project is that you take the urban one, need not to electrify them, but to manage that electrified grid properly. And the second is that to take a rural grid in India, which has been, which needs to get the electrification. So total costing of that project was around 30 crore and 30, 30 crore. And within that, almost this project itself took almost, I think, 5 crore. Huh? No, no, no. They need not to pay a single penny. There's a 5 years project. It started from 2017. It was supposed to end by 2022, but because of the COVID, it got delayed. And the second thing, you might be knowing, in 2019 also Trump came into power. Okay. He was also against that project. He don't want any renewable energy. He don't want any kind of sustainability. You know that that is also happening now as well. So he also stopped funding this project. So it got delayed 2 years more. So it got over in 2024. So actually this, yeah, it is running now. You can visit this two hamlets and you can see that this projects are running. And now the local authority is managing this. The project is done. We have done all the installments. First 2-3 years, like till 2024, we have managed from the Kanpur and the Roorkee. We have managed this all these hamlets, like from where the power is generated and where we have to sell, how the farmers can buy, not buy, like use, not to waste the energy. And what will be the primary, like the irrigation purpose, obviously, is the primary goal. Then comes to the residential sector. So first we have managed this till 2024, and now it is on the hand of the authorities, local authorities. Yeah, actually, we visited those uh, hamlets quite a few times. We have studied that what is their basic need. First thing is that their irrigation. They don't bother about their home. They first want their agricultural sector to be electrified properly. So that is the first goal. So for that, normally the solar panels have been installed. That is the first thing. Second was that their home, and they have a very good amount of waste from the village. Like it may be a leaves or it may be a like your home waste. So that is why this biomass plant was previously not into the plan. But because of that waste, we saw that okay, they have good amount of cows as well in their village. So that much of waste we can use for generating electricity. So this biomass plant was actually added almost 2 years later, like it is around 2020 or 2022. So, and with the batteries as well, we have installed a big amount of battery, almost I think 800 kilowatt of battery. Yeah, my PhD was actually under this project. My work is to manage this, like managing anything like urban grid as well as semi-urban, as well as like we have electrified few areas. First is this the rural. As a semi-urban, we took a Netra, like that is the NTPC Delhi sector. Okay, there we worked, and that is not electrified. That is actually made them sustainable. We have installed solar panel to replace the consumption from the upper grid. And then we took actually the South Delhi, that is actually BSES Rajdhani area. That is completely urban, very posh area. So there also we have seen that sometimes their energy consumption even goes very high. So how the BSES, that is the service provider at that place, how the BSES Rajdhani can reduce their consumption or reduce their peak energy demand. So there also we did with the storage, like the battery storage. Running cost of this plant is actually zero for the rural one, but now it need the maintenance. So whatever extra money we had in our project, we gave it to the local authority that at least few years they can do the zero maintenance. They can run with the battery life. If you install lithium ion, that will take around 7 years, 7 to 8 years. And if you go to the little bit costlier, as a lead acid or nickel cadmium, that will can last for even 15 years. But we have installed lithium ion because lithium ion is a fast acting. No, 30 crores is the entire project. This is almost 3 to 5 crores. Again, you have to put the biomass plant is fine. You need not to replace it for the 20 years. Solar panel life is almost 12 to 15 years. That is also good. We have installed a good quality solar panel. Battery needs replacement, I think, at 2030 or 2031. So that not replacement, I could say the good maintenance of that battery. So if you want to replace, then also it is fine. So that will cost around, you can say, 50 to 60 lakhs. Repaired, if they take care of it properly, like the dust is not on that and like it is secured, no one is damaging it, it can last for next 10 years. But actually the panel efficiency got reduced because of this external thing. Like no one is going to clean, it is actually damaged because of any reason. So if that is happening, then it is difficult to sustain with this rural microgrid. And we started it as a project, like the pilot project, to show them that you can make your village sustainable. It is not like that you keeps on complaining against your government or against your service provider that they are not giving us power, but you can generate your own power and make yourself sustainable. You need not to connect with your service provider, and you can get power as free. Just the maintenance cost, and that maintenance cost is actually UP government is ready to pay. It is not like that they need to, like the villagers need to pay. It is actually a distributed. It is not a single land we took. These solar panels are installed in a very distributed manner. Few solar panels are on the actually in the field for the irrigation. Some solar panels are on the rooftop. I think 2 or 3 lands we took only for the big solar park. This land is government. No village land we took, personal land. Yeah, we have monitored it for 2, 3 years, and we have seen that obviously the lifestyle of the people got changed because now they have started using those electrical appliances which was not there. And second thing is that the impact, first of all, their irrigation has been improved because that was their major aim, that they want solar pumps before electrifying their home. We need to also electrify their home. They don't have connection as well. So we have to put the poles, distribution poles, lines, transformers, everything. Okay. So before that, we have to install the solar irrigation pump. And that was their major goal. And that is served means done. Like आप उसके बाद कुछ भी कीजिए, हमें कुछ फर्क नहीं पड़ता. अभी नहीं, IIT अभी इसको bear नहीं करेगा. That has been actually, that is why it is handed over to the local authority. Now अब उनके ऊपर है कि वो कैसे चलाएंगे. Yeah, actually one committee has been formed with the village sarpanch, MLA, one representative from the UP government, that there is actually कुछ employment भी इसमें किया गया था क्योंकि इसके maintenance और इसको even run करने के लिए, क्योंकि हम तो बाहर आ गए, then someone has to be there to manage it. तो उसको करने के लिए भी locals को educate किया गया था. So ताकि वो थोड़ा spoil ना हो जाए, so we have kept a few people from, like we suggested few people from UP government. हाँ, ये 2 हैमलेट के लिए, लाइक जो छोटा-छोटा हैमलेट था उनका रिक्वायरमेंट पूरा सैटिस्फाई हो रहा. ओके. So now everything you have, like you have your renewable power, you have your uh, battery, everything. But if you don't manage it, then what will happen? Like what is actually our role? सब तो इंस्टॉल हो गया, लेकिन उसके बाद क्या? If you don't manage it properly, then the first thing is that your generation, like without electricity use, your irrigation machinery, जब तुम्हारा generation है, if you at that time you are not consuming, or you don't have a backup for storing, that means you are just wasting that energy. Actually, the solar panels has that capability, or it is installed with that capability. If you don't consume, then it will not generate to its maximum level. It has that controller with it. Okay. So first, second thing is that if you continuously run your irrigation to just to consume that solar power, then what will happen? You will just overwater your field. You will just overwater because sometimes you don't need water usage, but you are just giving watering them. Obviously, water wastage, equipment stress, because what I told that renewable power, our grid, what is actually been designed, it is almost 50 years back. And at that time, no one thought of renewable energy. No one has thought of solar panel. So it has been designed not to accommodate any extra solar power. It is only designed कि power generate होगा एक जगह पर और consume होगा एक जगह. Consumers can also feedback power. इसके लिए that is not been designed. So if you don't manage at the local level, then what will happen? If the connection is there, you will push back your energy to the service provider, and his network is not ready for it. So at that time, in the village, now we are seeing under voltage. Like आपने देखा होगा stabilizer लगाते हैं village में, क्योंकि voltage सही नहीं आता है, continuously fluctuate करता है. Your light भी वो dim होगा, bright होगा, dim होगा, bright होगा. It is because of the voltage fluctuation. उसको if you like if you have more, that is because if you don't have sufficient power to cater that load. Now you have more power, so what will happen? It will go to over voltage. Like आपको जितना voltage चाहिए होगा उससे ऊपर चला जाएगा. And if that happens, that is also dangerous for your this fridge, ACs, and all this equipment. And that effect is not restricted to the local level. That effect, if you can see in the larger level as well. Okay, so that is also the problem. Second, the last thing is the delayed watering and the economic, obviously, the energy losses, because you are losing your cheap energy. If that is the case, that means like ultimately you need that energy later. So you will just buy it. If you lose your cheap energy, if I have a solar panel, daytime I am not consuming, I am not storing, तो इवनिंग में तो मुझे चाहिए ही पावर. मैं तो घर वापस आऊंगा ही. तो उस टाइम पे मैं कहाँ से लाऊंगा? उस टाइम पे मुझे ग्रिड से ही खरीदना पड़ेगा. इतना सस्ता पावर खो के मैंने महंगा पावर खरीदा. तो अल्टीमेटली आई एम पेइंग मोर. सो व्हाट आर द बॉटलनेक्स? इतना कुछ तो है, सुनने में सब कुछ अच्छा लगता है, लेकिन एग्रीकल्चर और इलेक्ट्रिकल दो सिस्टम कंप्लीटली डिफरेंट है. दोनों का टाइम फ्रेम कंप्लीटली डिफरेंट है. इलेक्ट्रिकल इज एन इंस्टेंटेनियस सिस्टम. आप स्विच ऑन करेंगे, पावर तुरंत आएगा. अब पहले पावर नहीं था. आप स्विच का ऑफ करिए, अब मेजर करिए एट योर एंटायर लाइन, यू विल नॉट गेट अ सिंगल लाइक अमाउंट ऑफ करंट और सिंगल अमाउंट ऑफ पावर. कुछ नहीं मिलेगा. लेकिन आपने जैसे ही स्विच ऑन, विद इन अ फ्यू माइक्रोसेकंड आपको पावर मिलता है. हाँ कि ना? So that means it's an instantaneous responding system. Cut to agriculture. एक क्रॉप बड़ा होने में कितना टाइम लगता है? 3 महीना, 4 महीना, 5 महीना, 6 महीना. तो now you are trying to accommodate two sectors जो एक instantly रन करते हैं और एक 6 महीने में रन करता है. क्योंकि आपको कब दिखेगा? You want, आपने बीज बोया, you pluck your seed and you harvest your crop. So that is the आपको benefit. आपने renewable लगाया, आपको benefit मिला. Benefit in terms of what? How much crop or how much yield production you are doing. वही benefit है. आपने कितना बीज लगाया वो तो आपका benefit नहीं है. That is also your investment. लेकिन जितना बीज लगाया, हमें उस हिसाब से उतना रिटर्न मिला कि नहीं फील्ड से. That is my benefit. Okay. So the benefit you will see after 6 months. But operation you have to do instantly, or in a daily basis, or in an hour basis. So that is the major bottleneck of merging these two sectors. That the operation you have to do it now, but the benefit you will see after 6 months. And it is not guaranteed that you will see the benefit. So that is the major bottleneck. Like the time scale of each and every component is not same. You are generating power from your solar panel for the entire day, from 7 o'clock time to the 5 o'clock. But for this entire time frame, almost 10 hours, you are not going to water your field. अब 10 घंटे के लिए पंप चलाएंगे कभी? हाँ ना, नहीं चलाएंगे. लेकिन आपको पावर 10 घंटे का मिल रहा है. आप पंप नहीं चलाएंगे 10 घंटा, लेकिन 10 घंटा चलाएंगे क्या? उसके लिए आपको एक पंप से तो चलेगा भी नहीं. उसके लिए आपको बहुत सारे पंप लगाने पड़ेंगे. तो सबको क्या आप 10 घंटा चलाएंगे? नहीं चलाएंगे। आप दिन में 1 या 2 घंटा या 3 घंटा ही चलाएंगे या 4 घंटा चलाएंगे, ठीक है। तो जनरेशन आपका हर टाइम पे है। जो एक्शन आपको करना है दैट यू हैव टू डू 3 to 4 times इन योर डे, और जो रिएक्शन आपको दिखेगा दैट इज आफ्टर 6 months. So you have 3 different time scales to manage, and you have to manage it in a very efficient manner, otherwise आपको लास्ट में जाके कुछ नहीं मिलेगा. That is the main bottleneck of merging electrical sector with the agricultural sector. Second thing, whenever आप efficient management की बात करते हैं, you need the data. बिना डेटा के आप efficient management कर ही नहीं सकते. आपको efficient management करना है मतलब आपको पता होना है कि when your system needs water, तो उसके लिए पता होना है कि आपके सिस्टम में वाटर नहीं है. That measurement you have to do, and that is a continuous measure. आपको कंटिन्यूअसली आपके फील्ड को मेजर मॉनिटर करते रहना है कि कब उसमें पावर उसमें. हाँ, okay, so okay, sorry, my bad. So the thing is that you have your field ready with you, so whenever you need to measure that whether it needs watering or not, so before that you have to check the moisture level of your soil. Okay, so that means it is not like that ki after 2 hours some farmers came and checked the moisture level. So that is IoT device install is very easy to say, but is really the farmers are intended to install the IoT device? If you go to any village, will you see the IoT devices installed in the field? Installing solar panels is comparatively easier. You have your motor connected with the solar panel and that is done. But IoT device installment means you need someone to monitor that IoT data. Who will monitor you? There are thousands of farmers in that village. Who will monitor that IoT? And that sensors now needs extra management. That has to work properly. That is one thing is that the temperature sensor, the moisture sensor, whether they are properly taking the readings or not, that is also a bottleneck. So for that, your farmer has to be a PhD holder. So you have to expect that your farmer is a PhD holder. He knows how this IoT things happens, how the data is capturing at IoT level, and now it is coming to the mobile phone. It will see the, okay, now I have to turn on my irrigation, and then he will switch on from his app. So for that, this thing, you need a good sensoring system, and that is what he told, automatic system. Okay, entire thing needs to be automatic. Lekin before moving to other automatic, everything is before manual. And then the third thing, that is the multi-system correlation. You have your water system, you have your electrical system, and you have your food system, that is the agricultural system. So these three things you have to monitor properly. And the major thing is that your agricultural system is actually in the open field. Okay. And you are installing very sophisticated IoT device to monitor that open area. Very sophisticated. If something bad happens, if one drop of water goes inside the sensor, that sensor will completely stop working. So that level devices also need protection, like proper insulation, proper management. Okay. So these are the bottlenecks. So now where this AI can help you. Okay, whatever the automation, whatever the automatic system you can design, from where how you can make it automatic. So if you do it manual, then it is fine. If you want to do it automatic, then what kind of automation you have to provide to your system? The first one is that you need to forecast how much solar power you can generate. Okay. And that is not a local level thing. That is mostly a upper level thing, because this all four things are quite tedious work, specifically the first two. The second and the third can be third and the fourth can be done in the at the local level. So first is your solar power generation forecasting. That much how much solar power you can generate depending upon your climate. Second is how much load you have, not only at your irrigation level, but as well as your village level. Okay, how much power you need. Third is that how will you manage that irrigation and water management. You cannot install a very smart device there, because then that will give you like force you to put extra cost to manage that. So you are trying to reduce, let's say, 50 rupees every day for your reduction in your electricity usage. Now for that maintenance yearly you have to spend few lakhs. Like as an engineer, when I came to my PhD first, my went to my supervisor with a very beautiful idea. He said, "Ye karenge, wo karenge," and he asked me that, okay, everything is fine. Now tell me how much money I have to invest for this work. Then I told, sir, if you really install it, then it will take 30 lakhs rupees. Then he told, okay, now I'm asking you a story. Let's say you have a TV at your home. Okay, that's a very old TV, and it is what? That's a very old TV, and every day it is taking, let's say, 5 rupees. Okay, so 5 rupees means 30 days, 150 rupees I am spending for that TV only. Now I went to that customer and I asked them, yeah, new TV I have launched in my system that is taking 2 rupees. Okay. So actually how much money you are saving? 90 rupees. But the cost of this TV is 20 lakhs. As a customer, will you buy it? The first reaction. So you have to invest 20 lakhs to get the benefit of 90 rupees per month. So how many years it will take to recover that 20 lakhs? And till that time, your TV will last. जब तक वो 20 लाख आएगा, till that time the TV will go out of order and you are in to buy another TV. Okay, so the research or your work should be such that it is not only a cost effective in a present way, but it will also give the good return to the customers in the future perspective as well. Okay, so that's why the irrigation system, though it is an AI based, but still you can use fancy AI system like any kind of new AI, generative AI, or everything, but that will enhance your cost like anything. So what is the good trade-off between these two? And the last one is the predictive maintenance of the agroelectrical. That is the topic of my second lecture. So I will focus on that later. So I hope these things have been covered, like what is AI. So I will not explain this thing. This is the AI universe. So a bit about it. And I hope that you all know how the AI works, right? You have your system, you need to just train that system, see the output, and then give the feedback. And the AI technique can be of 4 types. Okay. One is rule based. So this thing I'm skipping. Okay. One is rule based. Anyone one knows what is any example of any rule based technique? So in fact, any rule based technique, name, specific name. Decision tree is not rule based. Majorly not rule. We keep it in the supervisory, supervised. Rules you can keep. Yeah, we can say that it is rule based and supervised, like it's a mixture of them. Then obviously the supervised, that is the decision tree, random forest, k nearest neighbor. Unsupervised learning, any idea about it? You know? And the last one, which has been now followed, that is the reinforcement. So are you aware about reinforcement learning? Yeah. This one, reinforcement. You are using ChatGPT? Do you use ChatGPT? That is actually a reinforcement. You ask same question you ask in ChatGPT and she asks in ChatGPT. Both of the time you will get different response. That is actually a reinforcement learning. Reinforcement learning says that you have a plan of action with you. Okay, when you fresh start you just open your ChatGPT account and you ask something. Whatever response you will get, after 10 chats or 20 chats or 1 month, you ask the same question, you will get different response. Why? Because by that time he learned you that what kind of response you encourage. Okay. So this is actually agent means your AI technique. Environment is you. So it has a series or library of actions with him, and it will implement one action. First, it will implement one action on you and see what is your response. If you say that, okay, I'm satisfied, bahut acha, very good. That means it will generate a reward. Okay, that whatever steps I took or whatever actions I took, that is a favorable actions like considering your environment. Cut to, if that is not, if you write, no, I don't want the response like that, I want it in a different way. Okay, that means that will add a penalty to his system. At the end, when the system will stops or complete its learning for the entire system, it wants to maximize its reward. That means it wants to learn your system better. Okay, so that is actually a reinforcement learning. It doesn't need proper data. Like, it will start from the scratch, zero idea. It will take one step ahead, see what is the response of the system. That can be any system. It will see it. If it is working properly or if it is favorable and good. If it is not, then it will impose another action and it will see whether now it is fine or not. Depending upon the several actions keeps on going. And at the later stage, at the end stage, it will see what actions gave me the maximum amount of reward. And if that is the case, then those actions are good for me. So those actions are desirable for the customer. And if it is not, whatever is given me penalty, that means I should not repeat it. That's why ChatGPT at the scratch state, it will give you one response. Very formal response. आप कुछ भी पूछेंगे, it will give you a very formal response. But now, after few chats, now it will start giving you the response like you need or like you want. Okay, so that is exactly the reinforcement. That is exactly the generative AI as well. So these are the learning parameters. So the first case, that is the solar power generation. How you can forecast your solar power generation with the help of AI technique. Mostly the ANN, artificial neural network, is the not I should not say best, but it is efficient. So many. These are my research work only. What I'm showing you, I did only in my lab, not me, my students. And data collection is actually, this data are collected during that project time, because we have to do a good survey to install all these things. Actually, you cannot say that Kanpur mein we can install the solar panel. First, we have to check whether that area has a good solar potential. If that potential is also there, how much? Whether that is enough to cater the load of the entire village. If it is also yes, how much, how big solar panels we have to install? What is the capacity of the installment? So for that, actually, we collected few data. Few apps are not software or apps, but yeah, obviously, few websites are there. One is SAM. Okay, that has been designed by NREL, National Renewable SAM. So that has been designed by National Renewable Energy Laboratory, US. So what they did, actually, you need to enter few inputs there. First thing is that the latitude and longitude of that area where you want your solar generation. So you can put any latitude or longitude. Depending upon that, it has the irradiation level and the temperature data of the last 10 years. Okay. After that, you have to select which kind of solar panel you want, because there are multiple variation of solar panels present. Okay. And everyone has their own efficiency level. One is 60% efficient, one is 50, maximum is the 61. 50, 35, even 20% efficient solar panel is there. What you see in our rooftop, those are the least efficient one. That is called the amorphous solar panel. Okay. That has actually been procured from the dust of that 60% one. That's why its efficiency is very less. So depending upon that, what panel you want, you select that panel, and what day you want, whether it is a sunny day or winter time or monsoon time, those things you have to put as an input data. And then it will give a very nice solar profile, that how much power you can generate from your solar panel of this capacity at this location at this time. So the few factors of solar power forecasting. First one is the obviously the forecasting horizon. That means you want for the day, you want for the season or intraday or for long time. Depends upon which kind of analysis you are doing. When we do the planning stage or we want to install the solar panel, we have to do the long term. That means 1 day, 2 day, one season. Even we have to take, let's say, we divide normally the entire year in 4 seasons: uh, summer, monsoon, winter, and like it's a mixture of your spring and autumn. So we take 4 seasons, and depending upon that, every season your solar, because the time also keeps on varying. Like summertime, you get your sunrise at 5 a.m. At winter, it goes to 6:30 or 7. So depending upon that time frame, we choose this forecasting horizon. Second, the weather classification. That means you want for which season or you want for which day. Third is the forecast model. That is which AI model. And then what are the input? That is the major thing. What you will input to your AI technique. Because AI techniques are blind, right? जो सिखाओगे वही सीखेगा. If you give them wrong input, it will give you wrong output. So these are the data mostly been fed to the solar forecasting. You see that is the first one is the temperature, irradiance, humidity, precipitation, all these things. Now, I hope you all know about the correlation, the mathematics, statistics correlation thing. I hope from mathematics you know it, right? So what is the correlation? Which will give you that how much one parameter depends upon the other parameter. So this is actually the correlation study with the different environmental parameters with the solar power generation. Obviously, first is the irradiance that has 98% correlation with the solar power generation. Second is your temperature, which has 76% correlation. Now you see the cloud type or humidity. This data is actually negatively correlated. That means if the humidity increase, even in a very good day, if the humidity increase, that will reduce your solar panel efficiency. What is actually been seen in the South India. The humidity of the South Indian states are very high, especially the Kerala and the Tamil Nadu area. Temperature, but you have a negative impact as well. If everything is positive, then it is fine. Like how much you have forecasted, you will get that power. But when you have a negative impact, similarly, you have cloud also there because suddenly it starts raining because of Paschim Ghat and Purva Ghat, like the western and eastern ghats. You have suddenly you have raining. So this impacts you have, but you have to consider those. If you don't consider your humidity and the cloud type for proper solar forecasting, then you will end up with some result which you will never see in your life. So that actually give you what area you want your system to be run or your uh, study to be done. Meteorological data, most of the cases you get from your meteorological IMD website. You get not very long term data, very difficult to get long term data from there. Now, after getting those data, you need to process them because, especially in our country, we don't have very good data storing facility till now. Like even when we wanted, like now we are doing few works for UP government, like the UP government agency, and we have seen that they don't even have their customer data. That how many customers are connected with a an area. That also they don't have. Even from their system, like electrical system, they don't have their how long is their line, what material they have used. They don't have any, they have not saved a single data for them. And without data analysis, any kind of analysis is very difficult. And if you keeps on taking major assumptions, कि शायद ये हुआ होगा, that will end up in something else. You need to go to moon, you will end up in Mars. So, and that happens in our research whenever we tried to do something for specifically for the Varanasi region. We suggest something. We have seen in our lab that this is a very good result, 95% accuracy. Actually implemented, coming out to be 65% accurate. Why? Because we assume so many good things for the system. And when it came into the picture, we have seen that जब site visit होता है तब पता चलता है कि जो सोचा था उससे कहीं आगे है. So, first thing, if your data is not proper, we have to assume few data. Okay, so that is the first. Second, if you see, because of your sensors, if you see that your solar panel power production or your temperature is coming out to be negative, but we know from Varanasi can never get negative temperature, right? That means that's an error, sensory error. So those data you need to modify properly and then scale it to the 0 to 1 range, because training an AI technique with a diverse range of data is not give you a good result, because your temperature ranges from how much? 25 to 40. Your humidity ranges from different. Your irradiation levels different from 1000 to 10,000. So everyone scales at different level, and but because your AI will not understand the unit, it will just see the digit value. Okay, some are in point, some are in decimal, some are in 1000, some are in 2000 level. So it is better to keep everything in a 0 to 1 level. That it is very easier for the AI technique to get the correlation between 2 or 3 factors. So remember it, whenever you will give a good feedback or a input data to your AI technique, any kind of AI technique, just downgrade all the data to the 0 to 1 scale. Like keep the average value as the best value and divide all the other values with the average. Then you will get your data from 0 to 1. Okay, or you can keep the peak value as your sustained value, like 7 kilowatt power plant. So 7 kilowatt is the my peak value. Now you see, you cannot go beyond 1, right? Either it is 0 or 1. It will be lie within that. So if you do that, then your entire series of the data will be within the 0 and 1. And at that time, you can see the correlation of that correlation factor, because every AI technique runs or learns from the correlation. So the correlation quantity will be very high at that time. Otherwise, let's say your solar irradiance is 10,000 kilowatt hour per meter square, and your temperature is, let's say, 40 degrees centigrade. That means these are the favorable condition for good solar power generation. But because of your panel is 7 kilowatt, how much maximum you can get? 7. Maximum 7. So one is 7, one is 40, one is 1000. So you see the changes between the numerical digits of this 3 input. Okay, it will never give you a good correlation factor. Actually, mathematically, if you calculate, like if you do it in a per unit basis or the scaling downscale to the 0 to 1 range, you will see that the correlation will come to the 99%. If you do it in the 0 to 1 range, which is the good, which is actually the scenario. But if you do it in the actual numerical values, like the 1040 and 7, you will see the correlation is 50%. And that leads your AI technique to an erroneous result. So this is a small case study with the data. So very shallow ANN model has been taken. And the error is, I accept it is a very high error. Applied on AN. No, not novel. These are like the preliminary study one. So novelty, if you see the forecasting novelty, then we have to go for a very deep neural network. Like you can say LSTM or bi LSTM network. Those are actually, the thing is that those are very fancy too for the research, but not for the implementation. If you ask any industry, like whatever research we do for the academic purposes, those remain in the pen and paper. They just come online, people read. And then we plan obviously from the papers like research articles and also from the implementable. If you see my research, I do mostly the simplification of a system because our real systems are all very non-linear nature. Nothing works proportionately with the other system. Okay. So that is not the case. It is not like that key. If there are 1,000 people, the and 1,000 will become 2,000, the electricity consumption will also become double. It is not the case. It will increase, but it will not become double. Same thing. If all the systems, if you go, nothing is linearly. But if you come to the industry and tell them, I want to implement my algorithm and I came up with a non-linear solution, they will never take your system solution. Because designing a non-linear system in a hardware level is very difficult. They want their system to be done in a linear manner, like solve linear equations, like x1 plus x2 equals to 2, solve just a linear formula, and matrix, like algebraic equation. So those are very easy to implement. So in my research mainly focuses to take the original system. Now, after that, you do few good assumptions, which are very close to your real time. And with those assumptions, you make your solution process easy that can be acceptable to the industry. That is actually my flow of research. And I prefer for my students as well. Because until unless you have a implementable result, that only remains in pen and paper and only in research article. And it get lost within few years. But if you want, like when I was in US, we started working on the same thing what I did in the PhD. I just extended that work. And one partner of my research was Avista Utility. That is actually the service provider of that area. And when I went at that time, we don't know all these things. So obviously, and we gave him a very fancy solution method. They told, just go back. I don't want all these things. For this solution to be implemented, I have to invest 10 million of USD. Why I will take for a single action? Because this solution protocols are not available to me. I have to put separate R&D for it just for your system. Now I have few other problems as well. So that is the thing. What I told for the TV example, you need not to give him a new solution. You need that, okay, his TV remains same. You have to reduce his consumption within that TV from 7 rupees to 5 rupees to 2 rupees. Your engineer should be like that, not to tell him to replace his system. So that is the main agenda of engineering research. Engineering solutions should not only be quick, it has to be the cost effective as well. So yeah, pre-processing technique normally we do like in the lab scale only, like we take the data and we see mostly the what are the data are missing. Like some data you will see obviously 0. That is in normal, like your irradiation and your temperature, those are normal data. And we take those data and by code, we just see that where you get the discrepancy. Let's say at the 12 noon, you have your solar irradiance level at the very low, like 100. 100 solar irradiance you will get at the night time. Okay. Like that is actually the lowest possible. Evening time. Night is 0. Yeah. Everything is coding, like automated. You cannot see those 5,000 and 6,000 data on your manual basis. You have to check everything in a coding basis. Python coding only, then you can take any platform. Normally, what we take first foremost thing is that you visualize that data. Okay, like you plot it Okay, and plot and see, like Python, you can use Julia. Now Julia is taking, uh, uh, so you just visualize that data. And if you see that, okay, now it is at from 7 to 12, irradiation is keeps on increasing and suddenly it's decreased and then again it is increasing. So that means something bad has happened to that time. Okay, and that is not the case that, okay, 12 o'clock, the irradiations falls to 100 and again at 12:15 it has raised to, let's say, 1,000. So this sharp change is not possible in a day. Like physically, it is not possible. So that means this error is not due to the like environment. This error is because of my sensors who has collected the data. So something bad happened at that time. So that's why at that time you have to do some assumptions, and that assumptions is mostly done by regression analysis. You can do it, or you can use any, like you can use the previous data, like the for the sunny day, other day, 12 o'clock, what is the pattern of the data? You take it and assume one data out of it and put that. Uh, Long term actually depends upon which kind of analysis you want to perform after this, because it's not self sustainable. It's a prerequisite study. Solar panel generation, forecasting, that you need to implement somewhere. Okay. If you want to do it for the planning stage, like what we did for that village, that our main goal was to make that village sustainable for 15 years. Okay. So you need to do that study for 15 years. Like you have to take the, even you have to take how the temperature is raising each every year. Every year, how it is increasing, how the global warming effect is continuously pushing us to the more hotter world. That also we have to consider. We have to consider how what will be the population growth in the next 15 years there at that those two hamlets. अभी सबके कितने बच्चे हैं और वो ट्रेंड कैसे चलेगा. Okay, those consideration also we have to take. So depends upon what is your time frame of analysis, whether it's a planning problem of 15-20 years, or whether this is a short term planning of 5 years, or you are doing it for today, that is 1 day system, or you are doing it for the 15 minutes system. So depending upon that, your prediction algorithm will also shrink. You have to take data. One thing, the best way, you take the previous 10-15 years complete data, but that will become a crores of data you have. Like you, if you take, and if your frequency of data is low, that means, sorry, high, then that means you will get more accurate result. That means if you can collect your solar or any kind of data, I'm not talking about only the solar power generation, if you take the variation in a minute basis, then whatever output you will get, that output is will have 98 to 99% accuracy, or even sometimes 100% accuracy. But let now think about, you have to collect 1 minute data for 10 to 15 years. So what will be the volume of that data file? Even some gigabyte level. Okay. So now the challenge comes to store that data. First thing is the storing that data. And the second thing is that to process that data. No normal computer can process that. Like your laptop or normal PCs, even if you have a GPU system, NVIDIA GPU, still it will fail to predict or process those data. So at that time, you need supercomputers. And supercomputer itself is a crores of rupees money. So you want to downscale your planning investment, say by 1 crore, and for buying that supercomputer, investing 2 crores. There is no point of all this thing then, right? Because Meteorological data is you can ask from the IMD. That you have to get the most sign that normally IITs we have, that whatever, because this is a national project, right? What I told is a national project. This is funded by Government of India. So this is a, so you have to approach to the government. You will not get anything from the government very easily. Okay. And if you start from the bottom, it will never reach at the top. What we felt for that UP government as well. When we went to the UP government with the proposal of reforming the UP electrical distribution network, we first approached to the senior engineer of NASI level. That is more beneficial. Now, but for that you have to do a trade off कि आप कितना डेटा लेंगे और उसको स्टोर करने का कैपेसिटी आपके पास है कि नहीं. Because now if you see, if you are aware of, one project call has came under RF, which is the Maha AI call, where government wants that, I will say in my, like, not the Maha AI call, but how, what they want, that I will say in my next lecture. But they want their AI, develop AI model for each and every sector, for climate sector, for agriculture sector, medical sector, for them, they want AI. But to make that AI sustainable, they are asking to take the GPU system from the MITI. MITI is the Ministry of Electronics and Telecommunication. And that budget of that total project is 30 crore. Like if one PI, he will get that project, that is a 30 crore. But there is a but. Within that 30 crore, you have to give approximately 20 crore to MITI for using their GPU. Because they have restricted 70%, 70%. If you want a very high, good valued AI system with a very good training data, you need an GPU system which is mostly costing 30 to 50 crore. So they are restricting that you cannot ask more than 21 crore from the MITI to use their GPU. You have to pay them for 21 crore. You can think to make just one AI system for a single thing, just for the medical equipment or for the climate action, you to develop or to model your system with that amount of data, you need to pay 21 crores to the Ministry of Electronics and Telecommunication. And that also they bought in thousands of crores. So is it possible for a single person or a single institute to invest 1,000 crores just for this purpose? That is not possible. So here comes your trade-off business. What level of accuracy you want, and depending upon that, how much data you can serve. So generally for, let's say, if you do it in our system, like if you do it in our laptop or a PC, you cannot think about, forget about even 1 day data. Normally what we do, you represent each and every season with 4 days. Okay, take variation of 4 days. Like one is when the season starts. At that time, what profile? One is the profile when the season is at its peak. That is one thing. Third, when the season is going to end. That is one. And the third thing, fourth one, when the season is transitioning one to another. Then what is the profile? So you represent your entire year 16 days. 4 season, 4 days per season, total 16 days for the entire year. So actually for the 10 years, you're taking the 160 days. Then you can do this training at your laptop. Now, if you go, when you need GPU, when you will take 1 day data, that means 365, 3650 data, 365 into 10 years, that data to process your ANN. If it is a simple ANN, then only. If now, if you go to CNN, if you go to LSTM, if you go to BiLSTM, recurrent neural network, gated neural network, you need higher computing facility. Depending upon what facilities you have, or you can invest how much money. Depending upon that, you decide how much scale data you can take. It is not in the reverse way, because budget is the main constraint of everything, even in the US. They will not give you $10 million just for a computer. Never ever. So this is this very preliminary study. You can see only one layer of hidden layers are given. So that, and with this very small time frame, but the error is obviously high. It is 10% error. Then the second case study comes, which is the load forecasting. Okay. So that is also depends upon the duration and the method, that for how many years or how many days or how many hours you want to do. If you have good amount of data, then you can go with this regression, ANN, fuzzy logic, CNN, LSTM, all these big networks. But if you have restricted data, then you have to go with the simple curve fitting techniques. Like you will just see this point, like the trends in the data, and you plot it like a mathematical function, that may be a quadratic function or linear function or cubic function or exponential function. Any function, you just represent it, and from there you just predict the next one. Okay, that is a very easy method. You don't need a good computing facility even. You just represent, and even MATLAB, Python, everyone have this curve fitting tool. Okay, you just give that Excel sheet, you want that curve fitting tool, it will give you the lowest error possible expression out of it. And there you just put the new input data value and you will get your output done. So here also you have your short term, medium term, and long term. Now, what are the data you need for the load forecasting? Obviously, first one is the weather. Whether you are doing your load forecasting for a summer time or for a winter time. Depending upon that, your load forecasting information will get changed. अभी जैसे यहाँ बैठे हैं. Now we don't need AC at our home, right? But at a scorching heat time, we need AC. So 2 days, two different weather, same customer, same time frame, but still the load is different. Second thing is the calendar. Whether you are doing your load forecasting for a normal day or Diwali night, huge change between these two things. Or any festival. Like I belong from West Bengal, Durga Puja. Like huge amount of electricity we use at that on those 4 or 5 days. So you take a 1 week in June, May and June, no one even comes out from their home barely, and you take October Navratri time. Huge difference in the consumption of the same area and same population. So second is the calendar. Third problem, which is normally been seen, is the rooftop solar. Now, why this is problem? Previously, I told that this is a very good thing. Now it has become problem for your load forecasting. Because let's say you have 7 kilowatt of panel with you and 10 kilowatt is your consumption. And you are consuming at the daytime your 7 kilowatt. So actually, how much you are buying from me? No, 10 you have, 10 is your consumption, 7 you have your local rooftop power. So how much you are buying from me? 3. 3 you are buying. Generally, I see she is buying 3 kilowatt as a power operator. I am selling her just 3 kilowatt. Suddenly one day started raining. Now you will buy 10 kilowatt from me. And I was not ready for it. Because I don't know even that you have a solar panel at your home. It is possible for me sitting in Lucknow and who has the solar panel in, let's say, Gorakhpur. It is never ever possible for a distribution utility to know each and every customer what appliance they use and what if they have rooftop solar or not. That is a problem, right? Even the agricultural sector. Let's say for few days the farmer went for holiday. So he will not run his irrigation pump. Or let's say which crop they have cultivated. If the crop doesn't need that much of water, he or she will not even run his irrigation pump. So if that is the case, so this solar rooftop solar actually mask your load profile. This actually mask your load profile. And that is not for a single customer. If you accumulate that for 1,000 or 2,000 customers, the amount of power deficit or amount of power difference is huge. So I was ready, let's say, for 3 gigawatt of power, and now you are asking 300 gigawatt from me. So I was not ready for it. So that actually creates a big problem. Fourth, economic condition of your customer. So if you see the Delhi region or if you see Bangalore region, those region needs power because you have commercial and industrial customers there. You have IT sectors there. So if you switch off your IT sectors, that means crores of money loss for those companies. Okay. So if your customer is a residential customer, he can afford to not have power for 1 or 2 hours. But if you have a commercial customer or an industrial customer, he has to get power 24/7. If it is a critical load, hospital or medical center or school or college, that has to get power at its running hours. Even sometime your big customers, even the residential customers, they also complain. If it is a high high society, high posh area, even like one incident even happened in California. Like California is the richest state of US. Okay, and they are ready to even pay in 2015, I guess. This incident happened. Actually, the US government, some their thermal power plants go out of order. Like they couldn't produce that much of power which has been required for their interstate. It is CAISO, California Power Sector. But California regions, you know that a Hollywood or the Hollywood celebrities, they stay in California. Okay, so they're very rich people. So, and CAISO or the utility service provider, they keeps on increasing the price of the energy. Previously, it was $3 per unit, then it went to $5, $7, $10, but still the customers are ready to pay. But they want electricity. They ultimately need to forcefully cut down the supply when it went to $1,000 per unit. But still the customers are ready to pay because those are millionaires and billionaires still staying there. So after that time, US government was forced to shut down their load. And that creates a huge nuisance there. So depending upon that, what is your economic condition? So that's why I told rural India, rural customers comes at the least priority level because they are not ready to pay you 100 rupees per unit. They will give you maximum 3 to 4 rupees. Now someone comes with 100 rupees, someone comes with 5 rupees, you obviously prefer the 100 rupees one because ultimately everything is need to be done in a profitable business. Then the consumer behavior, like which kind of loads they are using. And the third is the electric vehicle or your tractors or any kind of loads you have. So that is actually needs to be charged. If you have a battery, if you have a electric like this Toto or e-rickshaw, or you have an electric tractor, that also needs to get charged. So this is also a simple study with only 1 day data. This is a very old data we took because load data, getting a load data is very difficult. Even solar data you will get because meteorological department is there to give you the meteorological or climate data. Solar panels are also, you will get the solar panel data. But it is very difficult to get someone's load profile. You can imagine, like, you can even tell your load profile, right? These are actually some book chapters kind of work, not real research papers. Academic research will not take this research. These are all industry work, so they never take this kind of research for publication purposes. So this is the your data collection is done very before, like my supervisor, he had that data with him. And we just trained that we thought that might be this is the profile of a customer. Because if you ask the local service provider, he only have the billing amount. That is the monthly amount. That is not even a day amount. So predicting that is very difficult. So we just assume those things. So that's why you can see the error level. It is 16%. Like it varies from 12 to 16%. Sometime it went reduced, but most of the cases it is from 12 to 14%. Because it every technique, and because of that we have used ANN model which is quite deeper. But always using deeper network will not give you good result. That is also one thing that if you what you are actually training in ANN, your weights and the biases, right? Weights and the bias value. So if you are having more deeper network, that means you need to train more weights and bias. Sometimes it leads to a different level. Okay. Then it comes to a case study, another case study, which depends upon the fuzzy logic. Okay. This is for the actual irrigation system design. Okay. We took help from this paper, which has been, because this is a very quite old paper, you can see 2019, when we did that study for Kanpur region. We took help like reference from that paper for this irrigation purpose, and how you can make your irrigation system smart. So two things you need to decide. First thing, when to water your field, and for how long you have to water your field. Two things you need, right? कब करना है और कितना करना है. But how long, that depends upon what? How much power you are generated. Okay. If we have make it a standalone system, like it is only connected with the solar panel and the battery. So how much power you can take, it depends upon how much power is available at your battery level. That is one consideration. And for also watering, how much water is stored at your reservoir. You cannot take more water. Okay. So considering that, actually two fuzzy logics has been designed. One is at the resource level, that will see that how much resources you have left with your system. And the second is the irrigation FLC, that will tell you that for how long you need to water your system. So this is the overall algorithm where we see for actual purpose, like after measuring the soil moisture level and the temperature of that greenhouse, we took a greenhouse, small greenhouse. So for that energy requirement of that greenhouse, like to stabilize the temperature and to keep the soil moisture level up to the mark, up to the set value. So how much energy actually you need, and depending upon that, for how long you have to keep your irrigation system turned on. Okay. So depending upon that, how much water you require. So that is your requested resources. Okay. So, but obviously that resource is not available with you, because how much energy required, that may store at your system. If it is there, then it is fine. If it is not there, then you have to study how much available water you have and how much available energy you have. Okay. So then you calculate your error, and now you do your analysis. Okay. So first analysis is your fuzzy logic based management. That we do, that we take the inside temperature, we take the soil moisture level, and now we divide that entire system into few categories, because every category will give you different decision. Whether your inside temperature is very cold, that is one. Whether your soil moisture error, that means what is the desired level and what is actually been sensed, whether these are very close to each other. Okay. That means your temperature is also less, and your soils are also good, in a good moisture level. Do you need power? आपका मतलब your soil is good watering, is a good water level, and also the temperature of the greenhouse is at the most optimal value. Do you need to turn on your system? You need not to turn on your system for irrigation purpose or any purpose. So depending upon that, it shows that whether you have to go with a very short duration, or you have to go for a short, medium, long, or very long duration, depending upon the soil moisture level and inside temperature. So here comes the if then rule, that you will set the membership function. I hope you know that what is fuzzy logic membership function, that we set a if then rule for it. So if you see, if your temperature is very cold and your error for the soil moisture is also very low, then you have to water your system for very short duration. That means Ideally, it should be 0, but you cannot fix 0 in the if then rule. So we keep it at the very short. Depending upon that, come to the last one. If your uh, temperature is very high, your error is also very high. At that time, you have to turn on your irrigation system for a very long time. So you have to set those rules for your system to get a proper output or the decisions for your irrigation time. Now, depending upon that, now you decided your ideal irrigation time. That may be a 4 hours, that may be a 3 hours, 2 hours, 7 hours, whatever. But actually, to scatter that time interval irrigation load, whether you have that much of source or not, or that much of energy available with you or not. So that has been collected again with this another fuzzy logic theory, where it will say that error, that means how much you have and how much you need. If this error is very high and this load is also very high, your L error, that is your loading error or the water error, is also very high, then that means the error level of your entire system is very high. So multiply that error value with the desirable value, and then you will get your actual value. So though you need your plant to be watered for 4 hours or 5 hours, but if your error is 50%, that means you can only water it for 2 hours. So whatever is that, you have to be satisfied. Okay. So this studies has been done. So there is no result like captured result. We just implemented it. And we have seen that these things are working properly for a smaller system. We have not implemented for a larger system. So I cannot commit how it will do for the entire village. Analysis means that is mostly the coding thing we do. Like we set those if then rule in a Python code, and then we dump it in a microprocessor. Yeah, the actual data is that we have installed few sensors in a small greenhouse. Okay, that is why in IIT Kanpur mostly we have developed actually two centers. One center is called the SCADA system, Smart Grid SCADA system, which normally monitors the entire village electrical. And one center is developed just to monitor the agricultural system, all the sensory data and all these things. No, that is everything done with this 30 crore. Institute will not give you a single. Okay, that for any research in IIT level, you have to take money from outside. Yeah, my PhD is under that project only. Yeah, that's agricultural thing has not given me any publication. These are all like field implementable or deployable project. Like what actually they need. We didn't go to the village for like for the irrigation system. We actually went to electrify them. घर में power. We just went to electrify them. But their first and foremost condition was that कि first हमारे irrigation को electrify कीजिए. Then only you can do the other things. That was the village's main concern. They told we can survive without electricity, but if you really want to do good for us, this agriculture is our backbone. We have to first electrify this. Getting water for them, like from the borewell and all these things, is a very tiresome job. So they first wanted their agriculture system to be sustainable enough, and then do the rest of the things. So that is actually a joint project. So like there's a very big group. IIT Kanpur was the leader. Then we had IIT Roorkee, IIT Delhi, IIT Bhubaneswar, IIT Madras, and then few this local utilities like our UP government, UPCL. Then we have NTPC, we have BSES Rajdhani. These are all industry persons. Then we have CSIR with us, CPRI with us. So a big group from India and a similar amount of group from US, led by Washington State University, accompanied by MIT, Massachusetts Institute of Technology, Texas A&M, and your NREL laboratory, PNNL laboratory, Avista utility. So it is like a big consortium. It's a 30 crore invested by Indian government, 30 crore invested by US government. They don't, US is actually, their research cost is very high because they pay more to their researchers. So mostly they did the theoretical research. And India did, we did our the field deployment research. Because in US you will not get a single village which is not electrified. Even if you are staying alone, because I have seen few farmers, you are staying alone because their people don't want to stay together. They just want to stay with their land. If their land is very big, they just build their house between their land and they have no neighbors. They just stay alone. Okay. But still that person has a full access of electricity, full access of internet as well. So you cannot think of electrifying them, but that problem is there with us. So, and every IIT actually has few villages to take care of. In IIT BHU also, close to Varanasi, we have one village which we have to take care. And for that, we actually installed some EV charging stations there for the Totos and all these things that they can charge for free because the solar panel oriented EV charging station, they can just take power from free. So we have to do it, like for the social responsibilities the IITs have. And for that, we need to do multiple visits to the villages because it is easier, not even easier, it is difficult to convince the urban people and it is next to impossible to convince the rural people. Urban people are also not very resilient about the technologies. You, I don't know whether anyone is from Gujarat or that place or not. In the government of India, they have launched one scheme which is a smart meter scheme. This same actually what we did for this IoT in agriculture. The smart meter will say that no one will come to your home for billing. Whatever you have consumed, instantly that data will be sent to your service provider. Even the urban people are not ready for it. They don't want smart meter. No one, not this is not the problem only with Jabalpur. Yeah, it is the problem with the entire nation. Like in 20, I think 2021, the government has launched this RDSS scheme, revamped distribution system scheme, where they have targeted to install 30 crores of smart meters in the entire country. And still even 2 or 3 crores is not done. Yeah, so that is the problem. Like, and even I visited one distribution utility, which is in Madhyanchal Gujarat distribution utility. Even with the smart meter, people are spoiling it. Like they opened the meter, they short circuited within the meter. So these problems are there. This one are real. So this is when this we will only face when we will go to the field. That is why you don't do academic research for the industries or for the utilities. If you do, because we think that customers are very fair, the system is very fair. We know everything about the system, and we do this analysis and get the publication done. And whenever you go to the actual state, you will see nothing is fair and nothing is ideal at that stage. So with this, I will conclude my lecture that obviously the AI techniques are good, but the bottleneck is that first of that to get the data. That is difficult for a system, specifically for the agricultural system, because soil moisture, and even if you see that the if your watering system is not evenly distributed for the entire field, you will get the soil moisture level different at different places. But you cannot take the decision for per bigha basis, right? Or per katha basis. You have to take the decision for the entire paddy field. But this data keeps on varying for each and every location. So that is the one challenge with this application of this AI technique. क्योंकि AI technique will tell कि okay 4 घंटे के लिए उनको पानी से बहा दो पूरा. But some places, let's say where actually the irrigation pump is there, it is already deep into water. Closest field of that irrigation pump. And the farthest one is actually, it is not have a sufficient amount of water. So what will, जो closest paddy hai, that will get flooded with your watering system or water. So these are the real challenges whenever you will go to the actual field system and you will see what is actually happening. The greenhouse temperature, if you see, to maintain that greenhouse temperature, you have to keep the ACs properly on. But for that, the AC has to work properly. But it is a greenhouse, right? That means it has mud, it has dust, and that will reduce the lifespan of that AC. And every time you have to clean, like monitoring that whether your AC is working properly or not. If we set it at a 25 degrees centigrade, whether it is running in the 25 centigrade or not, whether its compressor is working fine or not. So those are the challenges, and that is how it has been done. That is my next sector. That is the predictive maintenance that we call the condition monitoring of a system, where we will see whether whatever machineries or whatever panels or whatever electrical devices we are using for this agriculture field, whether they are working properly or not. Okay. With this, I will end this lecture, and thank you.